Okay, so here's lesson 3, and it's going to be on integration with a substitution that's given to you. But first, what we're going to start with is a starter question. So here are 2 past paper questions. Can you pause the video, try this yourself, and then you get the answers on the next slide. Okay, so pause your video right now. Okay, and here are the full solutions. So both of them are worth 3 marks each. So pause the video and correct your work that you've done. Okay, so like I said, the next topic is going to be on integration with substitution, and it's a substitution that's given to you. So that's going to be your heading here. So integration with substitution. And just going to in brackets here, given, because we're going to be given what substitution that we're going to be using. And in some cases, you're not told the substitution. Okay, so I've got 2 examples. So I'm just going to go straight into it. So examples. Question 1. Okay, so everything I write down, you should be writing down too, because this is your notes, essentially. So the question is, find the integral of x cubed, bracket, 2x to the power of 4, take 3, close bracket, all of that is to the power of 4, dx, where u equals 2x to the power of 4, take 3. Okay, so that's your question there. Obviously, if you were to look at this, you might be thinking to use a product rule because we get 2 things multiplied by each other. But remember, that's only for differentiation, not integration. Okay, but here we're given what our substitution should be, so we're going to be using this to help us solve this. Okay, so the way that I do this is I like to split the page in half, and I do my working on the right hand side, and then the answer on the left. That's just the way that I like to do that. So what we do is I'll rewrite the integral here. So x cubed, 2x to the 4, take 3, to the power of 4, dx. Okay, so our substitution we're given is this. So u equals 2x to the power of 4, take 3. Now the whole point here is to change all of the x's into a u, and then we're going to then we're going to integrate with respect to u instead of x. Okay, so let's get rid of all of the x's here. So the first thing that's dead obvious is, see this part here in the bracket? That's just the exact same as this, isn't it? So I can change that full bracket just for u, because we know that u is 2x to the 4, take 3. Okay, everything else can stay the same right now. So that full bracket is just basically u. Okay, and that's one of the x's disappeared. I've got 2 more that I need to substitute out and substitute it for a u. What we're going to do here is actually differentiate u. So if you differentiate u, so it's du, and you're differentiating with respect to x. So that's why it's du over dx and not the other way around. So if you differentiate this as normal, it just gives you 8x to the power of 3. Okay, but we've just got a dx here that I need to swap out. So what we need to do is a little bit of rearranging to get dx by itself. So we've got a fraction, so all I'm going to do is multiply by the bottom for both sides. Okay, just pretend that's a fraction. And that's going to give you something like this. And then what I'm looking for is I want dx by itself because I want to swap it out. So in order to get that dx by itself, I'm going to divide by 8x cubed. Okay, so that's going to give you something like this. And the whole point of doing that is now I've got dx by itself and know what dx is, and that's going to be this. So over here, we're keeping everything the same, but I'm swapping my dx for that. Okay, so I want to get rid of all the x's, essentially. Just going to get rid of the brackets here. Okay, so dx is now going to become du over 8x cubed. Right, now you think, why have I done this? I've just now introduced another x in here. Okay, we're not ready for integration because I've still got two x's here. But can you notice that I've got an x cubed and an x cubed here? One on the top, one on the bottom. So they actually just cancel off with each other. So 9 times out of 10 it does work out really nice and you will be able to cancel stuff off. Okay, so all we've got here for this integral is actually quite a nice integration, just like this. Okay, so we're just going to integrate this as normal. So increase power, divide by the new power. So we're going to have u to the 5 over, I'm dividing by 5, but I've already got an 8 there. So 8 times 5 gives you 40. Don't forget about your c. Okay, but we're not finished just yet. So if I scroll up to the question was in terms of x. So you need to leave your final answer in terms of x. Okay, so get rid of the u again. But from the question we know what u is. 2x to the 4 take 3. So that's what I'm going to swap out. Okay, so everything stays the same apart from u. Just like this. Okay, and that should finish that question. So I've now got everything in terms of x and we're done. Okay, so feel free to pause the video to rewind it to make sure you've got this in your head. I'm going to go through one more example and then you can practice 6 questions by yourself. Okay, so this is going to be question 2. So the integral that we've got here is sine squared x cos x dx. And we're told that u is equal to sine x. Okay, so that's your question. I'm just going to do what I always do, split the page down the middle-ish. Let's go to our answer. Okay, so I always start with what's given to you and think, is there anything that we can swap out? I want to get rid of all the x's. We're told that u is sine x. Okay, so what I can actually do is swap one of the, because if I've got sine x here, that's just going to be u squared, isn't it? Because if u is sine x, I've got sine squared x. That means this part is just going to be u squared. Everything else can stay the same because I don't know anything else yet to swap out. We're going to take this and we're going to differentiate it. So same as last time, you're differentiating u, so it's going to be du over, is with respect to x, so dx is on the bottom. Okay, and the derivative of sine x is just cos x. So I want to get dx by itself so I can substitute it in. So multiply both sides by dx. You can do this in the one step if you want, you don't need to show all the working like I'm doing. And then I want dx by itself, so I'm going to divide by cos x. Okay, so now I've got dx by itself, so I'm just going to swap dx for this part here. And if you look ahead, you might see something that cancels out, which is good. Okay, so dx can be swapped for du over cos x. Now you can spot this, I've got a cos x on the top, I've got a cos x on the bottom. They cancel each other out. And like I said before, this turns into a very nice question. Because it is just the integral of u squared du. So what we're going to do is just integrate this as normal. So increase the power, divide by the new power, plus c. And then because your question started in terms of x, you need to leave this in terms of x. If I scroll back up to the question, we're told that u equals sine x. So what I'm going to do is whenever I see a u, change it for sine x. Okay, so this is just going to be sine cubed x over 3 plus c, right? Or you could rewrite this as sine x all cubed over 3, plus c. But what I'm going to put in here is a wee note. You need to be really careful where you put that cubed. So both of them will give you the correct answer, right? But not this. See if you write sine x cubed over 3 plus c, that would give you the wrong answer. So I would get in the habit of either using brackets or putting it in the middle like this. This is the way that I would leave this, sine cubed x. But it's up to you if you want to do that part, but do not do this part, okay? Because you will not get the final mark. Okay, so feel free to pause this video if you want to rewind it and look over those examples again. I've also uploaded questions 29 through to 34 on Google Classrooms that I'd like you to do by yourself. Please let me know if you're stuck at anything.